Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 91. So this problem says measurements made on circuits that contain large resistances can be confusing. Consider a circuit powered by a battery of 15 volts with a 10 mega ohm resistor in series with an unknown resistor R. And as shown in these circuits, a particular voltmeter reads 366 millivolts when connected across the big resistor, or 10 mega ohm resistor, and it reads a V2 of 7.317 volts when connected across R. So we want to determine what R is, and it gives us a hint to define RV as the internal resistance. Okay, so let's represent the 10 ohm resistor as R10, just because 10 mega ohm resistor doesn't make sense like that. And we, like the hint says, RV as the resistance of the voltmeter. So in the first configuration, which we'll call it configuration 1, we can find the equivalent resistance, and this is just given by R in series with two parallel ones, RV and R10. Okay. We know that the current in this configuration is just the EMF over the equivalent resistance. And we know that the V across R is given by the current times the resistance R, and this equals EMF minus V1. Okay, so from that we can combine these things and see that the EMF times R over the REQ in 1 is given by the EMF minus V1. Okay, let's move on here and let's talk about the REQ in the second configuration. Well, this is R10. Similarly, with RV over R plus RV. Similarly, we now have the current of the EMF over the REQ in the second configuration. And here we can see the voltage across the 10 mega ohm resistor as I2 times 10 mega ohms. And this equals EMF minus VB. So we can rewrite this as EMF R of 10 over REQ2. Sorry, this would be V2. And this equals EMF minus V2. So now we have two equations and we have two unknowns, which is R and RV. So let's solve the second equation for RV and substitute that into the first equation. So doing that gives us the first equation, which is R over REQ1. This equals EMF times R over R plus R10 RV, R10 plus RV equals EMF V minus V1. Now we have EMF R10 over REQ2. This equals EMF R10 over R10 plus RRV over R plus RV equals EMF minus V2. We rearrange that for RV and we get RV as V2 R10 R over EMF R minus V2 R10 minus V2 R. Okay, so this is what our RV is equal to, we can plug that back in over here. Now this is where things start getting messy. So let's add in this new page here. So we have EMF minus V1 equals EMF R over R10 plus RRV over R plus RV. Okay, so this is a lot of stuff I'm getting ready to write, but it's all going to simplify pretty easily. So this is EMF, and we have R. Oops. We have an R here. Write that lower. All over R plus R10 times VB R10R over EMF R minus V2 R10 minus V2R. So that was our RV, right? And on the bottom we have R10 plus RV. So again, that is V2 R10R over EMF R minus V2 R10 minus V2R. Okay, so this looks very complicated, but if you actually just either plug this in Wolfram Alpha or Mathematica or do the algebra yourself, you can simplify this much more than you probably could expect and see that this comes out to being R equaling V2 over V1 times R10. Simple like that, huh? But anyway, so this is going to be now, we know these things, so we can just plug things in. 7.317 volts over 0.366 volts times 10 mega ohms. If you plug all that in, we can figure out what R is, and it comes out to being roughly 200 mega ohms. Awesome.